Okay, guys, let's talk about elasticity. So we have really four sections in this. We'll talk about the price elasticity of demand, which is the main thing we talk about, and the formula for how we calculate that. Then we'll talk about what determines that. We'll talk about the relationship between price elasticity and revenue, which is super important, and then talk about some other demand elasticities. So let's say you're the manager of a public transportation system and operating costs have been going up like crazy and you're under pressure to boost revenues. What should you do? Should you raise your rates or should you lower your rates? Um, Price elasticity is what answers us this question. And this would be the same for any situation. Managers are always, they need to maximize profits. That's the goal of any business, is to maximize profits. And so we have to say, all right, how can we maximize our revenue? And then that's what we're talking about in this chapter. And then after the midterm, we come back and we start talking about costs and how those react in different types of businesses. So for this one, we're focusing on revenue, and elasticity helps us answer that question of how to maximize our revenue. Elasticity is the measure of how much one variable responds to another variable based on percentage changes. So we use percentages, not flat out numbers. And really what we're talking about with this one is how much one variable, so the quantity demanded, responds to a change in another one, the price. So it measures how sensitive one variable is to the other. When we were in chapter 3, we said if the price goes up, the quantity demand will go down. If the price goes down, the quantity demand will go up. And so now we're saying how much will it go up? So we know it'll go up, but we know that that reaction is going to be different in some products versus others. So that's what we're measuring here, is how sensitive this is. So we'll talk about how we measure this, and then we're going to talk about how we use that information. So price elasticity of demand is how much the quantity demanded responds to a change in price. And this is our formula. So percentage change in the quantity demanded over the percentage change in the price. So it's not the change in demand over the change in price, it's the percentage change in. So for example, if your price dropped by 1% and your quantity demanded went up by 2%, that would be 1 over 2, there's your elasticity. If the price dropped by 4% and your quantity demanded went up by, so let's do the first one, sorry. So this is the percentage change in the quantity demanded divided by the percentage change in the price. So not the change in the quantity demanded divided by change in price, but the percentage. So for example, if the price, if the price went up by 2% and we saw a drop in the quantity demanded of 1%. So a 2% change in price caused a 1% change in the quantity demanded. That would be 0.5, okay? If, however, the price went up by 2% and that caused a 4% decrease in the quantity demanded, we raised our price by 2% and the quantity demanded, or the amount we sold, went down by 4%, that would be -2. Sorry, those are both negative because this is going down, right? And this is going up. So a couple things here. Price elasticity of demand is always negative. So they're always moving in opposite directions, right? So this number is always going to be negative. So we use the absolute value when we determine what this means, okay? So for price elasticity of demand, we'll kind of ignore that negative sign because we know that this will always be negative because these two things move in the opposite direction. So if the demand for the product is price elastic, that means the absolute value, that means we're ignoring the sign, is greater than 1, okay? That means this is responsive. And really, the bigger the number is, the more responsive it is. So when we see this, we see the percentage change in the quantity demanded is greater than the percentage change in the price. So we would see that in that one example, when we saw a 4% increase or decrease in the quantity demanded, when we had a 2% increase in the price, that would be elastic. The example we got in that one, it was -2. The absolute value is greater than 1. We ignore the sign. The absolute value is greater than 1. That is elastic. If it's price inelastic, that absolute value is less than 1, and so it's not very responsive. We see the quantity demanded go down, but the change in the quantity demanded is smaller than the change in the price that caused it. So the percentage change in the quantity demanded is less than the percentage change in the price. So we did that example and we saw a 2% change in the price caused a 1% change in the quantity demanded. So we got -0.5. That's inelastic because that absolute value is less than 1. And then unit elastic is when the absolute value is exactly 1. So the percentage change in the quantity demanded is equal to the percentage change in the price. So a 2% change drop in the price caused a 2% increase, and this can work increase or decrease. So if the price went down by 2%, we would see the quantity demand go up by 2%. Again, all these are going to be negative. We ignore that. And so you ignore the sign. If it's greater than 1, it's elastic. If it's less than 1, it's inelastic. And if it's exactly 1, it is what we call unit elastic. Okay? The way it looks on a graph here, so you can see that, let's see if I can, on D1 here, D1 is flatter than D2. And so that means it's more elastic. The steeper it is, D1 is flatter. That's elastic. D2 is steeper. Oops, sorry, that's really ugly. D2 is steeper. It's inelastic. So the steeper it is, the more inelastic. The flatter it is, the more elastic it is. And so this is saying the same thing as the formula, it's just a little bit different. In both of these cases, we see a 30% decrease in the price, okay? So the price went down by 30 cents, and for D1, that caused us to gain 200 extra. So we went from 1,000 to 1,200. So a 30% drop a 30 cents drop in the price caused a 200 gallon increase in the quantity. With the steeper demand curve here and 2, that same 30 cents, that's still the same price drop, but we only gained 50 extra customers. So you can see the response on the x-axis here. Same thing is happening on the y-axis with the price, but the response on my x-axis is much bigger. And the flatter that curve is, the bigger the response you're going to see. The steeper that curve, the smaller the response you're going to see. So the steeper this curve gets, if that was even steeper, this might only be 20. And if that's even flatter, that might be up to a 500 increase. So flatter is more elastic. Steeper is more inelastic. And again, what you're looking at is how much did I change on the quantity demanded there? How much did I move along that x-axis? And the flatter it is, the bigger the reaction you're going to see to that exact same change in the price. So how do we calculate this? If you're not given the percentage, so in the one I said a 2% change in price caused a 4% change in the quantity demanded. Sometimes you're not given the percentages, but you're giving, when the price was this, here was the quantity sold. Like, for example, in this case, when the price was, let's say I'm using D1. When the price was $3, I sold 1,000. When the price dropped to $2.70, my quantity increased to 1,200. So we can use those two prices and two quantities to calculate that elasticity. So we use the midpoint formula. Mathematically, it's going to be more accurate. It's going to be simpler to see whether you're going A to B or B to A and all this kind of stuff. So the formula looks like this, which looks like a big scary formula, but it's really not that bad. You got two prices and two quantities. P1, P2, that's all you're doing. So this first part, the change Q2 to Q1. So that's the change in the quantity that you had. In our example, it went up by 200, right? That, and you put that over the average quantity. You add the two together and divide by 2 to kind of get the average. So this gives you the percentage change in the quantity demanded. And then that's over, you do the same thing with the price, the percentage change in the price. So that's the elasticity formula that we had at the beginning. Now we're just using two prices and two quantities to get it. So it's actually, like I said, it looks big. It's really not that bad. You got two prices, two quantities. That's it. So let's look at this guy. When you cut your price from 250 to 230, so you dropped your price by 20 cents, the number of gallons that you sold went from 2,000 to 2,500. So if we want to pop that into this equation here, okay, so this is price 1, and this is price 2, this is quantity 1, and this is quantity 2. Once you've identified those, you just plop them into the formula. So for this one, we do the quantity first. So the quantity went to 2,500 from 2,000. Oops. And then I'm going to average the two. So 2,000 plus 2,500 divided by 2 to get the average. Make sure you put Q2 first because you need to see how much it went up. In this one, we're going to ignore the signs, but in some of the other elasticities, the sign does matter. So it's important to get these in the right order that so you come up with a positive number when you need a positive and a negative when you need a negative. And then we do the same thing with price. So price 2 is 230, price 1 was 250. And then I put that over, I'm going to average those two together. So I do 250 plus 230 divided by 2. All right, so now I just solved that equation. So over here, I've got 2,500 minus 2,000, that's 500. And 2,000 plus 2,500 divided by 2 should be 2,250. Oops. 2,250. So that gives me 0.222. If I do the same thing over here on the price, I've got a negative 20 cents over the average of 250 and 230 should be 240. So that gives me a negative 0.0833. Okay, I'm just gonna, yeah. So what that really tells you, I'm just gonna kind of rewrite that in a vertical way because that's easier for me to see. 0.0833. That's the same thing. I just rewrote it this way. So what this tells me is that when the price decreased by 8.33%, that's my percentage change in the price, that caused my quantity demanded to increase by 22%. That's what that means in English. An 8.33% drop in the price caused a 22% increase in the quantity demanded. Right now, I can see that the effect is bigger than the thing that caused it. So I know it's going to be elastic, right? An 8% change caused a 22% change. So the effect is bigger than the thing that caused it. It's going to be elastic. So if I do this math, I get negative 2.7. That's the price elasticity of demand for this one. So that is greater than 1. The absolute value is greater than 1. So it's elastic. And that's all you do. Once you identify P1, P2, Q1, Q2, two prices, two quantities, then you just plug them in the formula. And you don't have to memorize it. Put it somewhere where it's handy, and then you're just plugging the numbers in. This example said, what if the price had only increased to 2,100? And like in demand, this was from another picture that I think I took out. So there we go. So we use the same prices, okay, that we used in the last one, 250 and 230, and Q1 will still be 2,000, but we're just changing Q2 to 2,500. Okay, so P1 is still 250. P2 is 230. Q1 is still 2,000, but now we're saying Q2 is just 2,100. So instead of a 500-gallon increase, we got a 100-gallon increase. So we just do the exact same formula that we did there before. And actually the change in price is going to be the same as what we calculated before because it's the same thing. But we'll just do the whole thing just for fun. So our formula is Q2 minus Q1. So how much did the quantity increase over the average, the midpoint of those? Q1 plus Q2 divided by 2. And then I do that. That will give me the percentage change in the quantity demanded. And then I do the same thing with the price. Price 2 minus price 1. How much did the price change over the midpoint or the average price? And that will give me the percentage change in the price. And so now I'm left with percentage change in quantity demanded over percentage change in the price. So in this case, quantity 2 is 2,100 over 2,000. And then we'll put that over the midpoint, 2,000 plus 2,100 divided by 2. And then the price is still 230 minus 250 over the midpoint, 250 plus 230 divided by 2. So now for the quantity, I have 100 over 2,050 is the midpoint there. So that gives me 0.049. And then this is the same as it was before. So that's negative 20 cents over the average there is $2.40. So that is negative 0.083. And so now I get, again, if you kind of want to translate that, you could, if you want it in percentages, you could take it times 100. So what this is really telling you is when my price dropped by 8.3%, my quantity demanded went up by 4.9%. So now the impact, the 4.9%, is smaller than the thing that charged it. I dropped my price by, that's my percentage change in the quantity demanded over the percentage change in the price. When I dropped my price by 8.3%, the quantity demanded went up, but it only went up by 4.9%. So that is smaller, so you get 0.59, negative 0.59, sorry, even though we ignore it, I keep putting it in because we do use it later, so it's just a good habit to get into. So negative 0.59, that is small, that absolute value is smaller, so we get inelastic. We had a small response. There was still a response, but it's small, and the response is smaller than the thing that caused it. So that's the formula. And even when we get into other elasticities, it's very similar. So same one. Okay. A vertical demand curve means that there's no response at all. It is perfectly inelastic. That is really, really very rare, very, very rare. Remember that to be part of the demand, you have to be willing and able to purchase it. So if the price goes up to a certain point, there's, the more the price goes up, some people are still willing but are no longer able. And the higher that price goes, the less able they are to buy it. So even if it's something like, you found a cure for cancer or whatever, everybody would want that, but not everybody can afford it. So a vertical demand curve would be really, really rare. And if it was perfectly horizontal, it would be perfectly elastic. Again, we actually might see that a little bit. Like if we'll kind of get to that a little bit later. If two things are absolutely identical and the price of one goes up even a little bit, nobody's going to buy that because they have an identical substitute for it. So that might be an example of perfectly elastic. And then there's the unit elastic when it's actually exactly one, which is sort of, in pricing at least, sort of your goal. So, but don't think because it's inelastic, there's no response. So inelastic and perfectly inelastic are not the same thing. Inelastic just means that the response is smaller than the thing that caused it. It doesn't mean there's no response at all. No response at all would be perfectly inelastic, and that's extremely rare. So just to kind of to summarize these guys here, the flatter curve is elastic. So in this case, a 40% change in price caused a 55% increase. So we get an elasticity that's greater than 1. It's a little bit flatter. That's elastic. Here you can see it's steeper. And that same 40% change in price only caused the quantity increase by 22%, so that's less than 1, that is inelastic. And here, this is unit elastic, right? A 40% caused a 40%, so that's like a 45-degree angle, I think. And so steeper means inelastic, flatter means elastic, and again, the flatter it is, the more elastic, the bigger this number is going to be. The steeper it is, the less elastic it is, the less responsive, and that gets smaller and smaller, and that gets closer to 0. This would be perfectly inelastic if it was flat. Any increase in price caused the demand. Means if you increase it even 1%, you're going to sell nothing. And in this one, this would be perfectly elastic, which again, very rare, but that means I don't care what you charge, you're going to sell the same amount. So within a certain range, you might get that, but ultimately, there's going to be people that can't afford it when you raise your price. So, super quick practice. When the price increases by 10%, the quantity demanded increases by 12. So this one already has the percent, so I do not need the midpoint formula, right? So all I say is percentage change in quantity demanded over percentage change in the price. So quantity demanded, or price decreased by 10% caused the quantity demanded to increase by 12%. I get negative 1.2. That's greater than 1, so it's elastic. And I can see that. A 10% change caused a 12%. The impact is bigger than the thing that caused it. It should be elastic. In the second one, you sell your items for $1 each and you sell 30. When you increase your price to $1.50, you only sell 25. So now I have two prices and two quantities, which means I'm going to use the midpoint. So here's price 1, and when I was selling at $1, I sold 30, so that's quantity 1. Here's price 2, and that's quantity 2. So now you just plug them in the midpoint formula, which is Q2 minus Q1 over the midpoint, Q1 plus Q2 divided by 2, 2. And then I put that over so that's the percentage change in the quantity demanded over the percentage change in the price, which would be P2 minus P1. How much did the price change over the average or the midpoint in the price? So in this case, that is 25. Where'd you go? 25 minus 30. So the quantity went from 30 to 25 over the midpoint. 30 plus 25 divided by 2. And that'll give me the percentage change in the quantity demanded, and I'll put that over the percentage change in the price. The price went up to $1.50 from $1, and I'll put that over the midpoint, plus 1.5 divided by 2. So my quantity went down by 5 over the midpoint, which is 27.5, and I'll put that over, my price went up by 50 cents, and the midpoint is $1.25. Oops. Sorry. Oh, goodness. Okay. I can't write on the bottom there. So what we get here is 5 divided by 27.5 gives me negative 0.1818 over 0.4. So what I've got is when I increase my price by 40%, 40, not 4, that caused my quantity to decrease by 18.18%. All right. So a 40% increase in the price, it caused my quantity to drop, but it only dropped by 18%. So I get negative 0.45. That's inelastic. Okay.